Hello, welcome to Applied Database 1. As a continuation to creating the database, we can include statements in the database that will assist in displaying information from one or multiple tables within the database. Or use columns from different tables to calculate the cost, price, or the total of an invoice, or the average, then display it to the user of the database. This can be done using what's called the view statement. In addition, we will learn about triggers, stored procedures, and other codes. SQL View is not an actual table within the database. Views can join and simplify information coming from multiple tables into a single virtual table or other views. It has no data of its own, but obtains data from tables or other views. We can use the select statement to define the view and select the columns that we would like to display using that view. A view definition may not include an order by clause. Views can represent a subset of a data contained in a table. Consequently, a view can limit the degree of exposure of the underlying tables to the other world. A given user may have permission to query the view while denied access to the rest of the base table. Views can be used to aggregate data such as the sum, the average, as we said, the price or the cost, etc., and present it or present the calculated results as a part of the data and aggregated view. Views can hide the complexity of the data and display certain fields only, partitioning the actual table into certain views. Views can join and simplify multiple tables into a single virtual table. Depending on the SQL engine that we are using, views can provide extra security. You can assign different triggers to different views of the same table. These slides provide an example of a view. To create the view, we can create view command or use the create view command. As indicated in the code, we assign a name for the new view. In this case, it's called the customer name view. After assigning the name, we start selecting the columns that we'd like to save in the new view. We can also assign new names for these columns, for example, the customer last name instead of last name only. The code will include the table name as a source from the required information. In this case, the view will fetch the information from customer table. Although that view has been created, it will not show on the screen. We did create it, but it will not show on the screen. Rather, it will be saved in the database as a consumer or customer name view. To see or display the results, we use the select statement with the asterisk, which can be used, which can display all records within the new view. If required, we can order by last name ascending or descending at that point. So not within the view itself, the code of the view, but within the select statement that we are going to use to display the new created view. That's when we use the order by. An updatable view is the one you can use to insert, update, or delete base table or rows. You can create a view to be inherently updatable, or you can create an instead of trigger on any view to make it updatable. A view based on a single table with no computed columns and all not null columns can be considered as an updatable view, and the view based on any number of tables with or without computed columns but contains the instead of trigger will be an updatable view. Other possible views, a view that is based on a single table but missing some columns can be used to update and delete the table but cannot be used to insert a record. Also, an update may be allowed on the most subordinate table in the view if rows of that table can be uniquely identified. So, can we embed the SQL code in programming software or a programming language? Yes, we can use what we call the SQL cursor. And the SQL cursors within an object-oriented programming can actually link the programming language to the database. It can select one row or one record at a time from the database. The SQL results will be processed as pseudo files, then displayed in the application programming language. This slide shows an example of a SQL code, SQL cursor in program code. The cursor will be first declared. You can see the SQL code within the cursor, then the cursor embedded within the loop. Once the loop done going through all rows, the loop will stop. The SQL cursor will be closed. As stated in the previous lecture, there are three categories of SQL statement: data definition, which we already addressed in the previous session; data manipulation, which we will address in details in a later session; and the third is the SQL persistent stored modules. SQL persistent stored modules is an American National Standards Institute and International Standard Organization, the ISO standard, for embedding procedural process programming functionality into SQL. Each database management system product implements SQL PSM in a different way, with some closer to the standard than others. For example, Microsoft SQL Server 2008 R2 calls its version Transact SQL TSQL. Oracle Database 11G calls it Variant Procedural Language SQL. MySQL implements SQL BSM but has no special name for its variant of SQL. Another SQL statement that can be used when creating the database is a trigger, which is a stored program or a program code that is executed by the database management system whenever a specified event occurs on a specified table or view. So there are certain types of words that can include to trigger an action. The three trigger types are before, instead of, and after. Each type can be declared for insert, update, and delete. So if you look at the combination, you can see that that will result a total of 9 trigger types. The before with the insert, before with the update, before with the delete, the instead of with the insert, instead of with the update, instead of with the delete, the after with the insert, the after with the update, and the after with the delete. Oracle uses all or supports all 9 triggers, 9 trigger types, while SQL Server and MySQL supports only 6 types. The SQL Server supports the instead of and after. The MySQL supports the before and after, but it doesn't support the instead of. When a trigger is fired, the database management system supplies old and new values for the update, new values for the insert, old values for the deletions. The way the values are supplied depends on the database management system product. Trigger applications include providing default values, enforce data constraints, updating views, performing referential integrity actions. This slide shows an example of a trigger. A trigger name will be assigned as usual. You know, when you create a view or you create a trigger or procedure, you have to assign a name. Then a type of a trigger will be stated. In this case, we have the after insert type, a declaration of the values that need to be inserted. The code will check if the work was listed before. If not, or if yes, an average net profit will be calculated. Then a comparison will be made between the acquisition price plus profit and the twice value of the acquisition price. The larger value will be selected. This is another example of a trigger. In this trigger, we are using the type instead of delete. We need first to make sure of the employee to delete is the last employee of the department or not. If the last employee of that department, don't allow deletion. If not, the last employee, then allow deletion of that record. If the user is trying to delete the last employee, a message can be sent to the user to inform them that the last employee, this is the last employee in the department and you cannot delete it or delete the record. The other one or the other code that can be used is called stored procedure, which is a prepared SQL code that can be saved, so that code can be reused over and over again. So if you have an SQL query that you write over and over again, save it as a stored procedure and then just call it when you need it. You can also pass parameters to a stored procedure so that the stored procedure can act based on the parameters values that is passed to it, and it can return specific results. In Oracle, it can be written in PL/SQL or Java. In SQL Server, it can be written in Transact SQL. Stored procedures can be called from programs written in standard languages, for example Java or C#, scripting languages, example such as JavaScript or VB script, SQL commands prompt, for example SQL Plus and Query Analyzer. Stored procedures and how to use them will be addressed in details in Applied Database 2 and will not be addressed in this course. So although I will mention a little bit about, I'll give you an example now, but still we are not going to address it in details. We are not going to use it. It will be used in the next course or the Applied Database 2 course. Using stored procedure will provide greater security since they are always stored on the database server. It decreases network traffic by using a whole procedure instead of using line by line and several times. Remember, I told you that this is the type of code that you are using frequently. So whether you want to use it frequently or you want to save it as stored procedure and then call it when needed, that will reduce the network traffic. SQL can be optimized by the Database Management System compiler. And the code for the stored procedure can be shared, which will result less work, standardized processing, and specialization among developers. This slide shows an example for creating a stored procedure. This stored procedure will be used to record the acquisition of a work. If the work has never been in the gallery before, a new row will be added. If the work exists, then the row will be used to identify that work. A new transaction will be added for the work, and the system date will be set as the acquisition date. This slide is just a continuation or continuation of the code that's been used in the previous slide. So what's the difference between the triggers and stored procedures? Stored procedures is a module of code that is called it's a module of code that is called by a user or database administrator, while trigger is called by the database management system when certain commands are issued. It is assigned to a database but not to a table or a view like the trigger. The stored procedures can issue, insert, update, delete, and merge commands, while triggers may issue, insert, update, and delete commands only. So it has stored procedures has more than the triggers. Stored procedure is used for repetitive administration tasks or as part of an application. That will be all for this session. If you have any questions, please let me know. Thank you and have a great day.